So in this lesson, we're going to look at how we calculate pKa values and how we use those to figure out the relative strengths of an acid or a base. So here's a series of acids. These are all weak acids. And so we don't talk about the Ka values of strong acids because remember, K is an equilibrium constant. It's talking about the relative amounts of reactants and products. And with a strong acid, all we have are our products because it completely dissociates. Weak acids partially dissociate, so we still have some reactants and some products. Notice here that we use the A subscript here as a Ka, and that's simply to remind us that we're dealing with acids. The K expression, products over reactants, means it remains exactly the same as we saw in chemical equilibrium. So just like when we found the pH value from the H plus concentration, we can also find the pKa values. And the reason that we use pKa values or pH values for that matter is just the ease of reporting the numbers. Rather than saying 7.5 times 10 to the minus 3 is the Ka of phosphoric acid, it's much easier to say the pKa is 2.12. That's also why the P definition includes a negative in there, because if I just take the log of this number, I would get a negative value, and we don't want to have to worry about forgetting the negative value, and so we take the negative log and get a positive number here for the pKa. And so what we see here is that our acid strength increases, okay, as our pKa value decreases and as our K value decreases, it becomes a weaker acid. So what we see here is we have weaker acids at the bottom and we have stronger acids at the top. So having either the Ka or pKa values will allow us to compare the strengths of acids. For a strong acid, we will have a large Ka value and a small pKa. For weaker acids, we will have a small Ka and a large pKa. When you're looking at numbers in scientific notation, if you're confused about what's larger and smaller, write it out in the standard form to see the numerical values. So the Ka values are given below for several acids. Which one represents the strongest acid? Remember that for the strongest acid, I want the largest Ka value. And so what I'm looking at is, if I look at these four values, I see that C has the largest Ka value. So what would be the pKa value for this acid? And if I look at the pKa values, which one will have the largest pKa value? Remember that the smallest Ka value will have the largest pKa value. When you're looking at scientific notation, be careful that you notice the negative signs. Remember that 1.5 times 10 to the minus 10 is a much smaller number than any of the other values.